Good morning, ladies and gentlemen, here in New York City. Good morning, good afternoon, good evening, if you're following along this general session out there on the World Wide Web. 12th Cloud Expo, we have this SDN theme, and we have our big data theme, but this time we're going to look at, this is my favorite title presentation, Software-Defined This. And to take us through it, Kevin Brown, CEO of Coraid. Let's give him a thunderous round of applause. 30 minutes with Kevin Brown.
Well, welcome everyone. Thanks for joining us. We're going to spend a little bit of time talking about infrastructure, talking about plumbing. Many of us, I guess, are in the Plumbers Union. We're here at Cloud Expo. So, one thing is for sure, there's a pretty dramatic change that's happening in the data center and just the architecture of how people are building stuff. And I think we all see it. We all see that change. We all see the need for that change. Data today is growing at 50% per year compounded. We've got all of these new applications, all these new changes. So what's that look like? It's scale out, it's commodity hardware, it's Ethernet, it's elastic. It grows and handles all of that dynamic kind of workload, and it's all multi-tenant and one-click provisioned. End users can go in just like they do at home on the internet and go and grab those infrastructure services. This is what the future looks like. Everyone has kind of agreed on that. Unfortunately, this is a little bit more where we are. Right, and and it's hard to get all the way to the future all at once. But in fact, a lot of the big legacy vendors, I used to work at one of them, they have not made it easy to get there. It's been very incremental change, what we like to call vitamins. And the solutions that they're still selling today look a lot more like, for example, big iron, Fibre Channel networks. This is what we used to run mainframes on. These very rigid silos. Here's your backup storage, here's your VMware storage, here's your database storage, here's your file storage. And then trying to turn that giant set of complicated silos into a cloud is very difficult. In fact, there's a lot of these vendors that are talking a lot about cloud, but you still have to do all of that back-end complicated configuration management. You're running this on 3 different types of networks with 7 different operating systems, and it's all manual. And that's where we are today. And so this is what we're going to be talking about today, of what's it take to go from where we are to where we want to be and where we need to be. And frankly, where IT is starting to realize that, hey, whether we're running a public cloud service or whether we're running a private cloud, what are the end users going to push for? And it reminds me a little bit of the iPhone and the iPad, where the CIO said, hey, we're not going to really support that. You're just going to have to live with corporate IT rules. And that person is no longer working at the company. There's a new one, and you can have your iPad, and they've got theirs too. And so this is that consumerization push, and I think it's going to drive a lot of change in the data center. So it starts out with the data plane. You have to do things to storage. You have to move data, store data. But in the future, as we're looking at some of these new types of data center architectures, it needs to be very elastic. You need building blocks that are very flexible. You need to have a scalable network fabric that's not all locked in and rigid, but you need to be able to flex. You need to be able to reconfigure it and not have to re-architect it all the time. You need to be able to go to petabyte scale. We have we did a buy a petabyte, get a petabyte free deal with one of our big customers. Petabytes are they're now the new building block, and we just are stamping them out. It's an incredible amount of data and an incredible amount of equipment that people are now putting to work in the data plane of handling their data. So there's something else that's happening though. There's a shift of value and a shift of a lot of the functionality up into what we call the control plane. And this is taking a lot of those Lego building blocks and then being able to turn a building full of them into a system, turn that into a service and deliver Amazon-style services. And that requires rich automation, programmability, requires tying in with the ecosystem, some of the open source and other tools that are out there. So it's really the combination of a very elastic building block data plane with this very flexible, programmable control plane. Those are the 2 fundamental ingredients that it takes to now move to what we call this software-defined data center, much more of this cloud architecture, and to deliver these Amazon-style storage services, on-demand scaling, dynamic ability to reconfigure and redeploy those assets very flexibly. So this is something that is not just one piece. You have to get a number of pieces right. So let's look at the data center here over the last few years. So compute, network, and storage. So in the old days, we ran small data on big boxes. And think of a database from Oracle or something. A really big one was a couple terabytes, right? My kids have 10 terabytes at home now. So it's a tremendously different set of data. But also you look at the boxes. These are big, expensive, mainframe-y looking boxes running on proprietary networks, et cetera. And what happened? Starting with the web and then with the x86 and Linux wave, you started to have scale-out computing. Now 10 gig ports are $300 a piece on networking. That rounds down to free. You have these scale-out network switches that are getting increasingly commoditized. And now guess what? Storage, the same thing is happening. Flash is really democratizing performance. It's democratizing IOPS. You used to have to run a whole rack full of machines to get a few thousand IOPS. Now you can get 50,000 IOPS in a single drive. So the difference is you can now start to use very different building blocks to tackle these workloads and not have to go to that old big iron mentality. And what have we seen? We've seen that there's a software layer that wraps around this. So you had x86, you had this incredible sprawl. What happened? The decade's headline was VMware wrapping itself around all of this to turn that into a system. So you have hundreds and hundreds of boxes, but it's one thing. You can have a template, you can have one click, you can program that, you have vMotion, all of these kinds of capabilities that turn it into an enterprise class system. That's the computing layer, and that has been tremendously powerful. Next, the networking layer, starting to get much more control. And you saw the Nicira acquisition by VMware. You see some of the open source stuff going on with Floodlight and OpenStack. You look at Big Switch, who's a partner of ours. There's a number of different facilities now for managing and taking many, many switches and turning them into one thing. The same thing is really important, maybe more important than any of the above in storage. Compute's kind of done, networking's, some people have some problems. Storage, everyone's got a problem with. It's chewing up 50% of the IT budget, and it's about 80% of the migraines. And if you look at where the performance bottlenecks are, where the scaling bottlenecks are, where the outages, all of the heartaches in the data center, a lot of them tie right back to storage. And so what do you need to do? You need to get to a much more flexible scale-out model instead of these monolithic big boxes, and need an automated control plane that can deliver that. There's only two companies that are doing that today. There's Coraid, and EMC has announced a number of initiatives. We have a lot of respect for those guys. They're the market leader. However, they're talking about 2014. Someday we're going to have some of that stuff. We've been shipping this since 2012 native. Every one of our customers is getting both scale out and this automated control plane. So it's something that we've been really working on for the last 3 years and delivering. And so we're pretty excited about this shift and are excited about working with some of our 1,700 customers at this point to do that. So if you look at the commoditization wave, this is moving down. So first you saw Sun, DEC, and SGI completely disappear. That was a $40 billion segment for computing. And now it's just crushed down to x86 servers for a couple $1,000, right? Even now going to ARM processors or sort of these very small dense compute nodes. Same thing happened all the way up and down the stack. So if you look and think about how we used to do it, we have a silo of here's my Fibre Channel storage for high end, here's my iSCSI storage for mid end, here's some NAS over here, here's some InfiniBand. There's a mishmash. We had all these different silos. In the new software-defined data center, this is much more about having lots of building blocks and then configuring them to meet different workloads. So you might start, for example, with a backup load and have a mix of SATA, SAS, and SSD drives that might fit into that. Then you might add Exchange, add a few more boxes. You might add a virtualization. You might add a number of web apps. And the idea here is what we call one tier for all. So instead of having all of these different silos, all these different boxes, all these different operating systems, all these different management interfaces to go do, and think of the complexity of troubleshooting that. You buy too much of one and you don't have enough of another, right? The idea is how do you get a common network called Ethernet to work for all of these, and then how do you do that in a way that you can then be very flexible to mix and match. So one of the things that is pretty unique, so I started out building clouds way back in the day, back in the 90s. I was building a lot of the big internet infrastructure, then came over to the enterprise side. So I've lived on kind of both of those. I saw this company and I was blown away because it was really that convergence of the two, enterprise class performance and feature set, but really in something that looks a lot more like scale out Amazon, Google style cloud. So there's a number of technologies we think are important to look at when you're constructing the building blocks here. So first is scale out. You need to be able to very fluidly add more resources and have that scale out linearly instead of having all of it bottlenecked through controller heads, for example, or through a single network connection. You need to be able to scale out the network. So we have a technique that we call ATA over Ethernet. It's been native in the Linux kernel since 2005, and now it's native in OpenStack. And what this does is essentially uses raw layer 2 Ethernet, so that very inexpensive off-the-shelf, Arista, HP, all of the sort of the basic building blocks using that layer 2 connectivity and doing it in a massively parallel and in a connectionless way. So that instead of having to set up these rigid multipathing, port bonding, fiber channel over Ethernet, all of these kinds of sort of old world technologies, it just gets rid of that. The big cloud guys don't do that. They don't buy fiber channel. They don't buy big boxes from big vendors. They piece together these commodity components and they write software that runs the building. The building is the computer. And how do you turn an architecture into something that supports that? And finally, how do you connect it to all of these different workloads? So the technique that we believe is very important to this, and we've spent now the last 7-8 years working on this, is what we call virtual DAS. So our driver makes the entire SAN, the entire shared architecture, look like your C drive. So the idea here is that if we can simplify the way that you can address storage from any point in that system, now you've eliminated all that configuration, all the multipathing, all of that nailing up of connections, and now you just have a liquid pool of resources that scales out both at the compute and network layer, and it can attach to all of that very inexpensive scale out compute hardware. Finally, it's a matter of how do you then tie this together in a programmatic way. So it's not only can you have those building blocks, but what do you do with a building full of commodity components? It sounds like a long weekend, or like 100 of them. So how do you sort of program that and have a wrapper around that to allow you to then design that once and then in an automated way roll it out. So in order to have that control, you need to aggregate, abstract, automate. This is very similar to what VMware was doing with those x86 servers, and you need to be able to deliver platinum, gold, silver classes of storage, carved out of these building blocks. So in the end, we want to make it easy for end users to say a few simple questions, to state a few things. What type of storage do I need? How fast and resilient? How much do I need approximately, but maybe I'm wrong? And then have the system then automate that and turn that into a set of best practice, sort of automated configurations that handle all of the RAID and snapshots and mirroring and drive types and sizing and best practices. Basically, the goal is how do we drive that out of IT for the end users? How do we drive that out of the everyday for the administrators? Let them express a policy once and then have it be able to be run and replicated like a recipe. This is how you do it. And this is something that is absent from the way that all the legacy storage platforms have worked. So it's also really important to be able to integrate this into the stack because it's not about the storage, it's about the stack. Because you can't deliver Amazon if you can't take the storage and the network and the compute and the applications and the virtualization and tie them together in a very programmatic, automated way. If that requires human intervention, here's what you end up with. We had, last year I spoke at the conference, one of our customers, a big bank, came and told us, they said at all times we have a backlog of 800 storage requests that are piled up on our desk. 800 money-making applications that aren't getting deployed because we have to go through all the manual pieces. So what they're increasingly looking to, starting with the public cloud, but now even many of the enterprise customers we talk to are now looking to use some of these more open source modern tools like Puppet and OpenStack, even System Center to tie this together. And this is really the layer we believe that you can use to get heterogeneous vendor support because you've now got even EMC, who's VMware's parent, they're contributing and participating in OpenStack. Everyone is now being forced to write their drivers, and some will write just a few to check the box, we're embracing it very, sort of very strongly because we see this is what the end users want. This is what the customers want, is that openness and choice. And we need to do a good job of making sure our building blocks work in those types of environments. And so REST, for those of you who are familiar with it, is a technique that we use and make every one of our commands, every one of our features now RESTfully programmable, RESTfully scriptable. And this is about, so if you want to use our interface, that's great. But if you want to use some other interface, whether it's open source or some third party, we want our functionality to be exposed in a way that you get to choose how you do it. So we're going to show you just a little demo of essentially how can we translate all these building blocks, this data plane and control plane, into something that can deliver very much an Amazon type experience. And this is something, here's our very easy interface. So what you see is you've got some SRX storage arrays, some different pools of storage. This is the basic storage management. So how do you make that very easy for people to click and go and set something up? But go beyond that into something we call storage profiles and repositories. So these are recipes. These are classes of service that the administrator can set up to deliver bronze, silver, gold, platinum, and make it very easy to then dole out multi-tenant storage and let people then select this on their own. So here, we'll show, you've got, slider bars that you can choose, bronze, silver, gold, and this will translate into different types of drives, different types of RAID configuration, different types of data protection options, and all of these are customizable if you want to come up with a different profile. The idea is that you can do this all through our RESTful APIs. You can even make that programmatic and tie it into your own portal. So the idea is with a couple of clicks, be able to set up. Here you've got your development and your production, and here we've exposed it in OpenStack. So if you look here, this is the Horizon interface that you use to set things up. There's volume, so we're going to go in a couple of clicks go create a storage volume. And what we've exposed is not only our AT over Ethernet sort of connector to do Ethernet storage, but here you see the pull-down menu. We're exposing these classes of service. No other storage company can do this today. In fact, we showed this to a customer. They were blown away. They said, this is exactly what we need because we've got all these different types of requirements, and we don't want to go through and manually configure them or have to pre-position them. So here we've now created this boot volume. And we're going to then show you how you can tie that into an instance, which is virtual machine, your application. So here you tie that in, select the image, and you're able to very quickly, now in the space of a couple of minutes, provision not only the storage from these predetermined templates and have all of that automated. There's no humans involved here. No administrators were woken up for this, right? So this is the idea of, can we, really start to, do something that's much more like Amazon. This is open source software, and this is us tying into it. And you could have different storage vendors if you wanted. You could have different network, different, computing layers, and all of that coming in. Here we are, minute and 30 seconds later, and we have a running application that is now running on that storage. So the idea here is, can we really start to drive out that complexity? So, for example, Credit Suisse put out a report recently talking about storage, and it said about 28% of the cost is CapEx for buying the equipment. About 72% is OpEx, just running around with all sorts of crazy configuration, all of these late nights and weekends and consulting dollars, and it's a mess. And if you look at the cloud, it's way to the opposite end of the spectrum. They're more like 90-10, 90% infrastructure, 10% labor, because they've gotten leverage. And this is what people are looking at. If you want to compete in the data economy, if you want to be differentiated from your competitors who have the same budget and the same number of headcount, you need to figure out how do you handle 10x more data. Instead of taking 8 weeks, how do you get it to your users in 8 clicks? Right? This is the new flipping around of it, because it used to be this was a cost center. IT was, storage, it's like, how do we just manage the cost of it and hit our requirements? It's flipping around to this is a weapon system. This is how you differentiate. This is how you go deliver new services. And in fact, even think about the telephone networks. So, they used to compete just on minutes, and just the price goes down, down, down. It's a race to the bottom. Where do they make it back up? They add software services, so call forwarding, three-way calling, friends and family, voicemail. These are all the services that they attach to then lock you in, to make it much more personal, to extract more value, and to really make it sort of tailored to what you need. And this is the exact same thing in the data center, and with the cloud providers, that's going to happen. There's a race to the bottom for basics. Everyone's going to have the basics. It's all the same, hardware from the Far East, and that's it, right? The trick is how do you build that software infrastructure that lets you innovate and launch services on top of that, and then do something that's very differentiated that extracts the value. So what we've shown is, in the old world, that old tangled, sort of legacy data center, this is what it looks like to go provision storage. It's many different steps, many different manual configuration points spanning multiple organizations, in fact. And so the trouble ticket bounces from the server guy to the networking lady to the storage guy, back to the multipathing software guy, back to the Fibre Channel. It's this crazy Keystone Cops experience, and it takes a lot of money. And by the way, this is what takes weeks and weeks to get stood up. And even though the big guys are talking cloud, this is still what you're doing underneath the surface. You're having to do all of this manual configuration and pre-provision it. And then they connect it and they say, check it out, we are so cloud, right? There's a big difference. What you need to get to is you need to then translate into much more automated stack provisioning. Spend your time as IT professionals defining classes of service, defining what are the new applications that we're going to help our users support. Think of Splunk as a service, Hadoop as a service, all of these things, and have that be a script. Do it once, get it right, do all of the security thinking, and now instead of having 1,000 manually configured things, how about having a set of services that always run right, that are very standardized, and it's a 1 or 2 minute operation for the end user. That's cloud. Cloud's not a place. Cloud is a way of doing things that is about how do you deliver services and how do you build the infrastructure to support that. And I just kind of start from the bottom of the plumbing, but if you don't get that right, you're not going to get the top right. So there's a lot of now people scrambling because this trend is becoming more and more obvious that, hey, this is turning into a commodity hardware game, and it's about the software you wrap around this. So everyone's talking about software-defined data center, software-defined networking, software-defined storage. So we'll take a shot. We'll define this a little bit. We think that this is about delivering physical building blocks as application services that can be controlled programmatically. So you need to do something that is leveraging commodity hardware economics. Everyone's going to end up there. And by the way, commodity hardware doesn't mean it's slow. It's wicked fast. We're getting 10 million IOPS per rack, right? So this is a very different new world in storage. Scale-out architecture so that you don't have to forklift out every time you outgrow whichever small, medium, or large or extra large box you were sold last year. Resource pooling, so you can just add a few more resources and then grab them up using a recipe approach. So instead of pre-provisioning and pre-deploying all of those things and then having them sit unutilized for months or years. You have to abstract so that you're not thinking about physical disks, physical RAID, physical networks, but really make this an expression of I need this type of storage and let the system do that, and automating that so that you can now have this one-click type of approach. And most importantly, making that programmable over time. As you need to deliver these additional services, as you need to start aligning this with the rest of your infrastructure, we need to make that very easy for you to program your infrastructure, not just manually configure it. So this is really putting it all together. So you need the data plane and the control plane. It's got to be elastic, scalable, has to really be measured in petabytes, not in gigabytes and terabytes anymore. And that rich control plane has to be much more programmatic than it's been in the past. It has to be tied into the ecosystem. And customers are saying, hey, look, this needs to be part of that open source system. So you have to take how do you find all of the SAS, SATA, SSD, Ethernet, take these basic building blocks and connect them in a way using software to deliver these classes of service, make it automatable. And now you can program it. You can have one-click provisioning for the end users, multi-tenant, secure, just literally a couple minutes like we showed you. Or you can now tie it into many of the new open source stacks and let your developers, let everyone go run wild with that. But the idea here is how do you really put this together into something that looks very different. So I got a couple minutes for questions.
Absolutely do. You have a couple of minutes. And just before those couple of minutes, I must just observe that I think it was Montgomery once divided all his soldiers into two types of people, simplifiers and complicators. And this gentleman is one of life's simplifiers. So let's give him a round of applause for his incredible presentation. And then let's give him like a really tricky question to see, because he's covered so much ground. Question, please, for Kevin. They're over there. Here I come. I got a feeling there's going to be lots, so I'll come fast. Could you pass that down to the gentleman? Perfect.
What's your view on disposing data? So many companies have so much data that they need to dispose. So if they dispose, they will have less storage and less problems to worry about.
This is a great question. So we demonstrated, last year when we launched our Ether Cloud, an automation where with one click we were able to do the networking, the storage, the compute, the hypervisor, and this is all scripted. So that was the deploy button. But one of the most popular features was the undeploy button. And so the idea is, if you had to go manually, after you hand out all that storage and do all the manual configuration, you're kind of done. It's lost. You'll never get it back, is sort of the reality of it. And so there's a separate conversation around data destruction and compliance, and that's a longer policy discussion. That can also fit into this automation framework. But the short version is that if you can deploy it automatically with a script, you now have the ability to undeploy it automatically and recapture those assets. So if you're using scratch space for Hadoop or whatever, you want to be able to redeploy that and give it from group A to group B very quickly. This is exactly the direction that you go to achieve that.
Thank you.
Great question.
Another question here from behind the pillar, Kevin. So this isn't an invisible trick. This is a gentleman.
Question about OpenStack. So are you looking into putting anything back? Sorry about that. Putting anything back in an OpenStack, so rather than having REST APIs and us integrating things, we can manage your storage through your toolset, but give it to the OpenStack, so through the OpenStack window itself.
Well, so the demo here was, basically, literally, we've done some of that initial work to integrate both our, Ethernet storage connectivity and those classes of service, those repository templates into there, so that can be done automatically. But if you want to roll your own RESTful scripts, all of that is now available, and you can just go run crazy and access our storage that way. So we want to have both for ease of use, so that the end user or a less sophisticated user can just go and do the easy things with a few clicks. But in the end, sometimes you need something different and custom that's you. And so we want to make that programmatically available.
Thank you.
Now, I don't know if this is a left brain, right brain thing, but this right brain over here, quieter than the left brain over there. So no questions from this side of the room. It's interesting. I'm going to note that. Anyone over there on the right brain or the left? Oh, I don't know which it is now. I've lost track. I don't see a single thing. You know why? Because they know if they sit here for another half hour, there's a free lunch coming up. That's what it's all to do with. Let us then please thank Kevin Brown, CEO of Coraid. You know they're at the show floor. I think Kevin's going to be around. The rest